All right, so first thing is put a number 8 on your sheet, and today we're going to learn how to use what we've learned about ions to predict ionic formulas. So first thing I want you to do is to highlight ionic bonds. Ionic bonds simply are the force of attraction that creates a chemical bond between ions with opposite charges. So very simply, opposites attract. In order for an ionic bond to happen, you have to have a positive and a negative neutralize each other. All right? So when you did your building molecule effect simulation, did you notice that sometimes when you threw your atoms on the table, they kind of pushed each other away? They were not compatible. They were not attracted to each other. So opposites always attract. Today you'll do an activity where you're going to predict the formulas, and you must have a positive and a negative come together to create an ionic formula. So ions are atoms that have gained or lost electrons. So ions are atoms that have gained or lost electrons, and they gain and lose their electrons again to get their octet. So atoms are going to be reactive until they get a set of 8 valence electrons around their nucleus. So an ionic bond is formed when electrons are transferred between atoms. If you did your online lesson, they literally show you, for example, sodium and chlorine. Sodium's outer valence electron will go to the chlorine. So physically, one electron is moving to another atom, all right? So atoms that create ionic bonds are usually created between a metal, and the metals create positive ions. Now, we didn't make our vocab card, so we're at a slight disadvantage. What do we call those positively charged ions? There's a special name for them? Cations, exactly. So I want you in parentheses to write cations. So the metals are the stuff on the left side of the periodic table, so we color-coded them red. Basically, to get an ionic compound, I have to have a metal, because metals are cations. And then the metals are going to bond with a nonmetal. And why are they going to bond with the nonmetal? Very simply, because the nonmetals are the anions. They're the negative ions. So in order to get an ionic compound, I have to marry a positive cation with a negative anion, and they have to neutralize each other. Now, ionic compounds are usually found as solids at room temperature. So put a star by that. A quick example is sodium chloride. What's sodium chloride, you guys? Good old table salt. So table salt is a solid. Sodium is my metal. It's on the left side of the periodic table. Chlorine is my nonmetal. So normally, you can even tell what kind of bond a substance has. If it's a solid, basically the atoms are having ionic bonds with each other. We're going to learn in Target 3-4 that the liquids and the gases that we have are almost all covalently bonded substances. So very simply, ionic bonds happen between a positive and a negative ion. Those opposites, they attract each other like a magnet. Now, oxidation numbers we just reviewed. Oxidation numbers show how many electrons an atom will gain, lose, or share when it creates a bond. And you can calculate the superscript or charge of an atom by recognizing whether it gains or loses electrons to get a full outer level. All right, so those are our oxidation numbers that we've been going through for a couple of days. Now, the one thing I want you to note is don't forget that octet rule of 8. And again, this is where some of you have maybe a couple little things in your thinking. When I look at an atom's valence electrons, I have 2 choices. I can either gain to get to 8, or I can lose electrons to get to a full level. So you always go with the smaller switch of electrons. All right? Now let's do the new learning. So here's the new stuff. So that's kind of a review of some of the things we've done and all the parts that are coming together. We are going to predict a formula between magnesium and chlorine. Magnesium and chlorine have opposite charges. So the first thing I'm going to do is I'm going to look up their oxidation numbers. So get your oxidation chart out. It's 6B. So everybody find your oxidation chart. All right, so find your oxidation chart. You need it right in front of you. You're going to be using this many times today. And I need you to be comfortable with this and how to read this. So can everybody click double check on your oxidation charts? Do you see how the metals are all positive numbers Okay, +3, +4. And these nonmetals, again, are the negatives. So negative means they like to gain electrons. Positives are they like to lose their valence electrons. So find magnesium. It's an alkaline earth metal. What is magnesium's oxidation number or superscript? And I need my leaders to lead, and I need you to talk loud because we're videotaping. +2. So put a +2. Perfect. Chlorine is a halogen. What's its oxidation number?
-1.
You bet. Perfect. All right, so very simply, hopefully you're getting very comfortable where the elements are and find them fairly quickly. So how do I know which element goes first in my formula? This is the easy part. Very simply, I write the symbol of the element that has the positive oxidation number first in the formula. So the cation goes first. In this case, which is my cation? The magnesium or the chlorine? Magnesium. So I always have positive go first. So in my formula, between magnesium and chlorine ions, magnesium is going to go first. That means that the negative oxidation element goes second. So the anion is second, and in this case, chlorine is the anion. All right? Now, just so you know, we can have more than 2 elements in an ionic formula. When you are done with today's activity, you're going to learn about polyatomic ions. We kind of have talked about those in Target 3.1. So you're going to be able to make more complicated formulas, but for now, we're starting with just 2 elements, a positive ion and a negative ion. Now, keep in mind, we must form neutral compounds. So the next step is we're going to determine how many atoms we need of each element, so the sum of the oxidation numbers is 0. The sum of the oxidation numbers is 0. So let me ask you this. Does a +2 and a -1 equal 0? No. So what we have to do is we have to figure out how many ions do we need of each element, and we're going to use that to determine the subscript. The subscript tells us how many we need so that the positives and negatives cancel out. Now right now that probably doesn't make sense, so let's draw a quick picture and let's kind of get a visual of the sizes of these ions. So we're going to make subscripts to predict how many. So go back to the top. If I were to envision magnesium, it's got a +2. So draw this about the same size as what I have it. So magnesium is a +2 cation. Chlorine, I want you to envision, is half the size of the magnesium. It's only a -1. So do we all agree a +2 and a -1 do not equal 0? So guess how many chlorine ions I need to offset that magnesium? 2. So I want you to draw a second one. Do you see how a +2 and a -1 and a -1? So this is +2, this is -2. That creates a neutral compound. So what I have to do is, how do I know my subscripts? Very simply, I count how many I have. How many ions of magnesium is this? That's 1. How many ions of chlorine do I have? 2. So Mg goes first, Cl goes second, and I put a subscript of 2 on the chlorine. And why do I put the subscript of 2 on the chlorine? Because I need 2 Cl -1s to offset that magnesium. Okay? So let's go through a couple of examples. This is weird. It will get better and it will get easier, but it's just strange to begin with. Let's go to beryllium and oxygen. Find beryllium on your oxidation chart. It's an alkaline earth metal. What's its superscript or its oxidation number? +2. Can you find oxygen? What is its oxidation number? -2. So Gavin, did you catch who goes first, beryllium or oxygen?
The cation.
The cation, exactly, which is?
Beryllium.
You bet. So it's going to be Be and then O. Will 1 ion of beryllium neutralize 1 ion of oxygen?
Yeah.
Yes. So if I were to visualize this, and again, I'm going to have you draw pictures, and eventually some of you won't need pictures anymore. Some of you will need the pictures for the whole time. They will neutralize each other. They're exactly the same charge. They're exactly the same size. So in today's activity, that's one of the things you're going to do to help you kind of recognize how many I need of each. So I need 1 ion of beryllium and I need 1 of oxygen, and bam, they neutralize each other. A +2 and a -2 equals 0. Do you all agree? So I need 1 of each. Go to the back side. Let's do another one. So on the back side, I need you to look up the oxidation numbers of calcium and chlorine. So what's calcium's oxidation number?
+2.
+2. What's chlorine's oxidation number?
-1.
All right, so +2 -1. So who gets to go first in my formula? So calcium and then chlorine. Will one calcium neutralize one chlorine? Who do I need more of? Chlorine. So how many of them do I need total? Two. And again, if you want to visualize this, calcium, its ion is twice as big as chlorine's ion. So do you see why you need two of them? I need two -1s, so the 2 goes on the chlorine. I need 2 ions of chlorine to neutralize 1 calcium. Last but not least, the third one you're not going to like, but I promise it will make sense eventually. So find phosphorus on your periodic table. What is its oxidation? -3. What is barium? Okay. Ooh, what's going on here? So I need the positives to cancel out the negatives. I can't have any fractions in a formula. John Dalton said they're whole number ratios. What could these both turn into mathematically so they could cancel each other out? 6s, exactly. So let's draw a picture because some of you will see it with the picture before you'll see anything. Here's Ba +2. Here's my phosphorus -3. So if I double my phosphorus, do you see how I have a -6? So guess how many barium +2s I need to get a +6? And I didn't draw this exactly to scale, but do you get the idea? And again, everything I write on my sheet, you guys write on your sheet. This is weird, this is different, and having pictures definitely helps us recognize it. So, in my formula, who gets to go first, phosphorus or barium? How many barium ions did it take? So I have a subscript of 3. How many phosphorus ions did I need? 2. Now here's a shortcut. I have 3 and a 2. When you get to these complicated ones, all I can do is I can just switch their numbers. So phosphorus is a 3, so I'm going to put barium's here, so you can just swap the 2 numbers and you'd be okay. All right. Now lastly, let's learn how to name these. Naming is the easy part. So how to write the name of an ionic formula? We're going to write the name of the positive element first. That's easy. We're going to write the name of the negative element second. And when we do the second element, we have to end it in I. Okay? So again, the positive one is the cation. We name the cation first. You say the name of the second element, except you dropped its normal name at the end. So what's Li? What element is Li?
Lithium.
Okay, so lithium just stays lithium. What is S? What element is S? Instead of saying sulfur, I'm going to say sulfide. Okay, so sulfur turns into sulfide. That's how you name an ionic compound, so it's pretty darn easy. Now let's do 3 more, and let's kind of move away from the cards and see if you can kind of figure some of these out. Find bromine on your periodic table. Bromine is a halogen. What's its oxidation number?
-1.
And what is potassium? +1. Who goes first? K. And Br goes second. Again, only capitalize the first letter of an element. Will 1 ion of calcium, sorry, not calcium, potassium neutralize 1 ion of bromine? Yes. So what would I call this thing? K is potassium, yep. And then instead of saying bromine, bromide. And again, it's kind of weird at first, but you definitely will get the hang of it. So bromine becomes bromide. Look at aluminum and chlorine. Can you predict the formula? What is aluminum's oxidation number?
+3.
What's chlorine?
-1.
Who goes first? Which one? Aluminum. So capital A, little l, capital C, little l. 1 ion of aluminum will not neutralize 1 atom of chlorine. Which one do I need more than 1 of? How many would I need? 3. So again, if you wanted to picture aluminum as a +3, it's 3 times as big as the chlorine, which is a -1. So it's going to take 3 little -1s to get me that. So Al is aluminum and Cl is, and instead of saying chlorine, I say chloride. So aluminum chloride, I need 1 atom of aluminum and 3 atoms of chlorine. Today when you do your activity, remember, do we ever put 1 as a subscript in a formula? No, so be careful that, like aluminum, we wouldn't put any subscript. It's implied it's only one. Last but not least, sulfur and sodium. What's sulfur's oxidation number?
-2.
And what's sodium's? Who goes first? Will one sodium neutralize one sulfur? Which one do you need more than one of? So I put a subscript of 2 on there. Again, if you want to see a visual, sulfur would be twice as big as the sodium ion. So this is why I need 2 sodium ions. So Na stands for sodium. And then the S, what would I say the S name is? Yes, so instead of saying sulfur, I say sulfide. So these are actual, real, everyday compounds that exist in nature, and very simply, to create an ionic bond, you need a positive cation and a negative anion, and you gotta get their charges to be neutralize each other. All right? And that's it. All right, so what I want to have you do next is find the activity. The activity is going to